Today we're going to be working on another MacBook. This is an A1708 MacBook. This is a non-touch bar USB-C 13-inch MacBook Pro. It appears to be having issues due to liquid damage. Let's open up the bottom of the case and see what it looks like on the inside. So if we look inside this MacBook, it doesn't look too bad. It has minor corrosion over here, and it has some corrosion by the backlight circuit, and it has some corrosion by the TPS 51980. If I had to guess, the lethal corrosion killing this MacBook is not going to be the backlight circuit, it's not going to be this stuff by the trackpad, it's going to be what's by the TPS 51980. The TPS 51980 is going to be responsible for your 3.3 volt rail, your 5 volt S5 rail, and your 5 volt S4 rail. Without these rails, the machine will not work or turn on. They are the most integral rails, in contrast to the backlight and the stuff by the trackpad, because who really gives a crap about the trackpad? You don't need a trackpad. What you need is a trackball. I don't care if this machine is a trackpad when I'm done. I could care less, because when I'm done with this, I'm going to give the customer a trackball. And if they don't want a trackball, they clearly don't have taste, and they have no business being my customer. So let's go on and take this board out of the machine and see what it is that this board is doing. I can't reach anything in there. Look at this. The amount of space for my iron is non-existent. I can't even touch that stuff up. Like, the T30KN will not even fit in there. Wow. That's crazy. I think there's a backlight sense line there that went out. Yeah. I see a broken current sensing trace there. Alright, so the issue here we're going to have is no backlight. And as can be seen here, this probe point that's missing, this is for going to be backlight current sensing. So if I look up U8400 and we look up pin 9 on the chip, this is going to this resistor over here. And this is a current sense resistor. There's going to be a really low voltage drop across this resistor, and the voltage drop across the resistor is going to be proportional to the amount of current that the system is using. So this over here is going to be a current sensing circuit. So if this trace is destroyed, if pin 9 is totally broken, then it's going to see a permanent voltage drop, because it's going to have 8 volts here or 12 volts here and 0 volts there. So it's going to turn off the backlight circuit. And a result of turning off the backlight circuit, it's going to be no backlight. And if there's no backlight, then the computer is going to wind up in my queue. So let's take a look at that. Let's see if we can bring that back to where it was before. So we're going to have to find out where this goes and run a little jumper wire inside the board. Alright, so let's see where pin 9 is supposed to connect to. That's going to a resistor on the other side of the board. Oh boy, that's going to be quite the jumper wire. Okay, so we got to run a jumper wire to the other side of the board. This seems like a great job to do tomorrow. Lewis, why are you still at work? I am still at work because there are MacBooks that need to be fixed. Alright, so we're gonna solder a new LED driver on here, and then run a wire to the other side. Okay, so we add a little bit of flux. Now we are going to get a new LED driver chip, which, by the way, if you need a new LED driver chip, you can find them at store.rossmangroup.com. Alright. Alright, so now it's time to get that current sensing wire running. Which ones do you like flat, like wiggle wiggle, and which ones do you gently press down on them? I gently press down on QFN packages, where I can see all the connections, and I wiggle wiggle the ones that are ball grid array, meaning there's balls everywhere. It's not just on connections on the outside. Okay, so we have to run a wire from this side of the board to the other. Yay. Because I don't see a via here. Or is there? Is there a nub? Ooh, nub! Yes! Yes! Nub! Show me the nub! And by nub, I don't mean noob. Ooh! Ooh! Please tell me that's not a ground plane. Mm-hmm. Ooh! I see you! I see you! Can I even solder to you, or are you just going to break into pieces the second I touch you? There we go. There we go. So we dug, we found the nub, and now let's see if this has a backlight on its screen. Let's see if it works. Someone said that it's an awesome repair. We don't know if it's fixed. This could still be a dead pile of junk. Let's see if this works. Yeah, 30 to 60 milliamps. Alright. This one will have to wait until tomorrow. I am getting tired, running out of steam. So we're going to work on this one tomorrow when I'm fresh. I have been streaming for 5.5 hours now. Let's get started on this MacBook. So we were working on this one yesterday, remember? So see what we did here? We ran a wire to that little via. Look at that. Look at that. I was hoping that would be good. But after we were done with all that, the thing didn't even want to turn on. So now let's take a look at the TPS 51980 area. Now, keep in mind, this was actually turning on prior to us running this jumper over here. So I like to look back to the last thing I did before something stopped working. So I ran a jumper to where I thought backlight current sensing was. There's a chance that when I dug into the board that what I was actually hitting was ground. So first thing I want to do here is see if PP bus G3 hot is shorted to ground. And it is. But it wasn't shorted to ground prior. So this was not shorted to ground prior to me running this jumper wire. So I'm going to unsolder this jumper wire that I ran yesterday for what I thought was backlight current sensing. Okay, now let's see if we're still shorted to ground on PP bus G3 hot. We're not. Yesterday when I ran that wire, I thought I was running it to the via for backlight output, but that via was destroyed, and when I dug into the board to try and find the nub, what I actually found was ground. So I wired my backlight circuit directly to ground. Great job, dumbass. So let me show you what was going on here. So here we have the backlight circuit. And on these machines, Apple decided to give people a break on these constantly burning LCD connectors and destroyed fuses by burned up boards by putting a current sensing circuit in. This is a resistor that has a really low resistance. And the backlight driver over here is going to measure the voltage at the beginning and the end of that resistor. If it sees that there's a big voltage difference, it's going to assume that the system is using a lot of current, and then this transistor is going to turn itself off because there's a short to ground somewhere or it's using too much current to keep it from blowing up or doing something bad. This over here is my PP bus G3 hot backlight input. And what I did, because I'm a dumbass, is I actually soldered this straight to ground. So I thought that when this nub was broken, what I thought I was doing is I thought that when I dug a little bit that I found the nub and then I soldered it to it. But I didn't. I actually soldered it to ground right inside the board. No good. So what I'm going to have to do, hopefully before I throw up, since I'm not feeling... Uh-oh. Okay, shouldn't have said that. What I have to do here is run that wire to the other side of the board, which I was hoping to avoid doing. That's not going to be fun. So let's go ahead and see where this goes. So that pin on the LED backlight driver is going to be pin 9. And you're going to the other side of the board. And that's going to be going down here to this pin, which is right here. So that's where this wire is going to have to go. Okay, we can do that. That shouldn't be too difficult. And hopefully after we do that, we have LCD backlight. Okay, so we're going to take this wire and place it on this MacBook. Let's try tweezers next. Oh boy, the nauseousness is coming. Uh-oh. Must fix MacBook. Cannot get nauseous. MacBook is not fixed yet. Cannot throw up on MacBook. Would like to throw up on MacBook. Okay, now we turn this around, and this wire is going to have to make its way around the board to this area over here. We're going to run this wire around here. This is so not... This is going to be bad. Oh, Jesus. I have no trust in this wire. Okay, and we're going to run this all the way to that pad. First, we're going to see if this turns on, with the amperage it takes. Then we're going to see what it outputs to a screen, if anything. Alright, so we're taking 600 milliamps. So this machine is capable of turning on. Now we're going to see if it produces a picture on the screen. Okay, so we're going to plug this in and see if we get an image or a question mark folder. I'm shooting for a question mark folder here. So let's see what voltage we get on backlight output. Alright, so it appears that this now appears to have a question mark folder, which means that we have fixed our issue. So we had two issues on this MacBook that I'm going to go over. So the first issue that we had on this MacBook was that the 3 volt and the 5 volt rails were not working properly due to there being corrosion around the TPS 51980 chip. And if we look here, you'll see this was where we originally had our corrosion, around the TPS 51980 IC. The second issue that we had was a backlight issue. We had corrosion around U8400. U8400 is the backlight chip. Now, what I did here, I thought that what I could do is fix the current sensing circuit because pin 9 over here is where the corrosion was. This via was broken right here. And this is a current sensing circuit. The way a current sensing circuit works is there's going to be a current sensing resistor over here. And there is going to be a small voltage drop across it. The voltage drop across the current sensing resistor, I will not go home. I have MacBooks to fix. My fever will get better when I fix my MacBook. The more of a voltage drop there is from this side of the resistor to this side of the resistor, the more current is going through it. Now, between here and here, this was broken. And since that was broken, this transistor is never going to open. Because if it thinks that there's 12 volts here and 0 volts here, it's going to think, oh my God, we're using millions and millions of amps. This is never going to turn on. So I tried to find the nub where I could attach this to this. I tried to do what it is Mark Schaefer and Jessa Jones do at iPad Rehab very often, which is find the nub. Because sometimes if you scrape down into the board a little bit, you can find the nub, and that's what I did here. And I thought that I found the nub. I thought I found it. You could see where there's a nub. You see this little, it looks like a set of eyes over here. So this is where this current sensing one's going. This is where this current sensing one is going. And that was not actually a nub. That over there was ground. I dug a little too much. Either that, or it wasn't that I dug a little too much. It was that the probe point was likely damaged entirely. So we ran a wire to that point, and I tried to run the wire in the same direction as the trace in the board. So the trace in the board was going like this. So I don't want to have a wire going like this, because then you have a very small, teeny tiny point where they cross, where you have connection. I wanted the wire to be running like this, right over it, so that it would make a better connection and be stronger. So you can see that this trace is going up and to the right, and the wire is running along it as well. We are going to re-ultrasonic this board to get rid of that corrosion over there. Not corrosion, the flux residue and all that. I'm going to use some of that green UVH 900 stuff available at store.rossmangroup.com. Don't delay. Buy some green UV curing mask at everyday low prices on store.rossmangroup.com today. And after that, this machine should be good to go back on the way to the customer. And hopefully they'll stop calling me and asking me for status updates while I'm sitting here with a 102 fever. So I am going to take some more vitamin C water over here, drink it, and then we're going to move on to the next MacBook. Vitamin C water. Your health is more important than MacBooks. I wish. Unfortunately, I have one purpose in life. It is to fix MacBooks.